All right, so for part A, let's find, the question is f of 4 plus f prime of 4 plus g of 4. Okay, so f of 4, go to where 4 is on the f graph, look at the actual y value. This is an algebra question, and we get -2. For f prime of 4, we need the slope. So here, the slope, well, we should think about the tangent line, but the tangent line will align with this line segment here. So that slope, let's see, rise of 2, run of 4. So 2/4. You could write that as 1/2, but I think it's natural to see it as 2/4. What about g of 4? Again, an algebra question. Well, we don't look here or there, because those are limit questions or calculus questions. We look where there's a solid dot, and that y value there is -5. Sure, this simplifies, but let's not worry about that. Now, if we go to part B says f prime of 5. Okay, so we go over to 5, and same deal, right? So at 5, the slope, remember derivative is the slope of the tangent line, the slope is still 2/4, or still 1/2. For part C, what do we have? For part C, the question is to find p prime of -2. We're given that p of x is equal to f of x plus g of x. Okay, well, what do we do with that? Well, first let's find p prime of x. Due to the sum rule, we can say p prime of x is f prime of x plus g prime of x. So then p prime of -2 is f prime of -2 plus g prime of -2. And so f prime of -2, we go over here, we get the slope. So when x is -2, we need the slope. And that's going to be, looking at the line segment, see 2 up, 4 over, so 2/4, rise of 2, run of 4, plus g prime of -2. So go to -2 here, get the slope. Oh, let's see, so right there, the tangent line will align with this line segment. See, that's going to be 1, 2, 3 units down, and 1, 2, 3, 4, 5, 6 units over. So -3 over 6. Let's say that the rise is negative, and then the run is positive. Okay, this is truly 1/2 plus a -1/2. That ends up being 0, but let's not worry about simplifying. We're trying to get to the big ideas here. Part D, same idea, just with a different function. So part D, we've got find k prime of -2. We were told that k of x is f of x times g of x. So that means when we find the derivative, k prime of x is, well, we got to use a product rule. So first times the derivative of the second, g prime of x, plus the second, g of x, times the derivative of the first, f prime of x. So then k prime of -2 is f of -2 times g prime of -2 plus g of -2 times f prime of -2. So f of -2, we go over here. The actual y value looks to be a +2. G prime, so here we had an algebra question. Here we have a calculus question. G prime of -2, go over here. Oh yeah, that was the slope we just computed as -3/6. Okay, plus g of -2, so we go here for the actual y value, which is 3. And then f prime of -2, we go back over here for the slope, which we had earlier computed was 2/4. Okay, again, we won't bother really simplifying this. Let's move on to part E. Now part E, we've got j prime of 3, but j of x, let's write that first. So part E, j of x is g of x quantity squared. Now your call, whether you want to rewrite g of x as j of x as g of x times g of x, or you could just leave it as g of x quantity squared. J prime of x, so if you write it out, g of x times g of x, then j prime would require the product rule, right? But it, as written, to find the derivative requires the chain rule. So 2 times the inside, right, times the derivative of the inside. Okay, so then, okay, and then, part E, the question was j prime of 3. So j prime of 3, just taking this line, replacing all x's with 3's, j prime of 3 is 2 times g of 3 times g prime of 3. So that's 2 times, okay, g of 3, we go over here, right where x is 3, g of 3. So the actual y value looks to be 2. And then g prime of 3, so we go here and look at the slope, which appears to be 1. The tilt of that is like 1 up, 1 over, 1 up, 1 over, yeah. or you could say the slope is 2 over 2, okay? So final answer there is 4. Part F. Part F, ooh, same general idea. Here we're told that z of x is f of x over g of x. So then z prime of x requires the quotient rule, right? We don't just differentiate the top and bottom separately. This is not a L'Hopital's thing going on. So the bottom times the derivative of the top, so f prime of x, minus the top, the top times the derivative of the bottom, all over the bottom squared, g of x quantity squared. So then, to get z prime of, what was the question? Z prime of -5, all these x's need to become -5s. Sorry, I'm using the power of the board to just replace all the x's here with -5, because otherwise I'm going to run out of room. Okay, and then let's g of -5. So we go over here, and the actual y value appears to be 1 when x is -5. F prime of -5, we go over here for the slope. The slope appears to be right there at, let's see, a rise of -4, a run of 2. So -4 over 2, or -2 is the slope. Okay, copy the minus. F of -5, we go over here to the f graph for the actual y value. There's no prime. So the actual y value looks to be 1, 2, 3. And then g prime of -5, so we go here for the slope. So at that point, the slope appears to be, well, let's see, if we start right where that intersection is, we go up 1, 2, 3, and over 1. So the slope appears to be 3. Then g of -5, oh, didn't we already get that? Oh, that was right here, this number, 1, but that should be squared. I get that 1 squared doesn't change, but let's just write that squared to account for it. Okay, part G. Part G deals with r prime of 5, okay, but r of x was given to be quantity g of x to the 4th. So r prime of x, due to the chain rule, is 4 g of x to the 3rd times chain rule g prime of x. So then r prime of, what was the number in the question? 5 is equal to 4 times g of 5 cubed times g prime of 5 once, right? So 4 times, let's see, g of 5. Actual y value there looks to be 1. Okay, 1 to the 3rd though. I get that 1 to the 3rd is just going to be 1, but let's just try to make it kind of followable here. G prime of 5. So we need, right there, we need the slope. And so it looks like the steepness of that, well, just based on, I get that's not filled in, but we can still pretend it is to find the slope. So from there, how do we get up here? We go up 3 units, and we go over 1. So 3 over 1. Slope is 3 over 1. Okay, that's part G. What about part H? And part H and part I. So part H is the limit. Part H is the limit as x approaches -4 of g of x. So we look at this graph, right? And go over to where -4 is, hide this with a ribbon, right? And then ask, if we go from the left and the right, do we have a guess of what the y value is? And we would guess, getting both ways, that that would be a 4. Right? So as x gets close to -4, the y value gets close to 4. There are x's and y's involved in this process. The other question we're asked here is part I, and part I is the following. Part I is the limit as x approaches, I believe just, +4 of the same function. So over here, we hide this with a ribbon. So we don't see that dot, we don't see this or that. We just hide that and then ask what's going on here. And this limit does not exist because the limit of g of x as x approaches 4 from the right is equal to -2, and the limit as x approaches 4 from the left of g of x is equal to +3, and these numbers don't equal. If these one-sided limits are not the same number, then the two-sided limit does not exist.